about truth. I believe my faith is true, but there's a difference here mathematically. It's about things that can be proven, all right? It's not only about evidence for proof, it's about actual proof. But do you know that nothing in the strictest sense, not even our mathematical stuff,
common ratio.
proven in the strictest sense. Let me turn this off. Because when you go back, the existence of numbers, the existence of all this stuff, there are some assumptions. They're called postulates. And we accept them as true, and then all this whole world of math is built on top of that. If any one of those could be proven false, this entire world of math would crumble. That's scary, isn't it? Yeah. It all comes down to some stuff that's just accepted as true.
Then we have to write essays all day
Yeah.
and
Back
read
to word notation for math?
and learn
Is that
grammar.
Back to word notation for math?
Yeah. Okay, let's, all right, let's suppose we have the sum, don't get tricked. K equals 0 to infinity of 1.1 to the k power. Tell me what it does. Can we calculate its sum? What is R? What's R? What is it that's being raised to a changing exponent? 1.1, that's R.
Yeah, that's all.
Does that satisfy this condition? No. 1.1 is not less than 1. So if it does not satisfy this condition, can we use that formula? No. What happened in all cases where absolute value R was not less than 1? They converged or diverged?
Diverged.
Diverged. Diverges.
Yeah, sweet.
Problem's finished. Okay? So if the absolute value of R is not less than 1, it diverges and you're finished. You cannot calculate the sum. There isn't one. All right? There isn't one. All right, here comes another one. Let's suppose we have the sum as k goes from 0 to infinity of e to the negative k power. Now, due to time, I won't sit here and Socratically question you. From algebra, we know that e to the negative k is equal to 1 over e to the k, correct? You have a negative exponent, move it down, it becomes positive. Also, this can be written as the sum, as k goes from 0 to infinity, of 1 over e to the k like this. Now, tell me what R is. R is 1 over e. And the absolute value of 1 over e, is that less than 1?
Yes.
Yes. So, this condition is satisfied, meaning we can use this formula. If that's not satisfied, you can't use it. Now we can. So, the limit as n goes to infinity of s of n will be the limit as n goes to infinity of a. What is a? A is the first term in the series. So a, yes, you're correct, 1. So a is going to be 1 over e to the 0 power. Because that's the first thing here. That might be a 1 there, then you would use 1. That might be a 5, then you'd use 5. 1 over e to the 0, which is?
1.
1. And by the way, we don't need this limit thing here, sorry. We're just going to use the formula, a over 1 minus r. So a is 1, r is 1 over e. Here's the r that we determined, here's the a. Now, 1 minus 1 over e, that's like e over e minus 1 over e. Which can be written as e minus 1 over e. And so now we multiply by the reciprocal, e over e minus 1, times 1 is just e over e minus 1. And yes, that is the infinite sum. If you carry this out to infinity, e to the negative 0 plus e to the negative 1 plus e to the negative 2, carry that out infinitely, the infinite sum, it converges to e over e minus 1. Converges. Let's look at this on decimals. So here's our series, e raised to the negative k, I'll put x here. And we just said that our sum, so I'm going to write y equals, is e over e minus 1. That did not work. What happened here? Oh, I'm sorry. This is wrong up here. Let me put this in now, tell you what I just did. Times 1 minus r, which is 1 over e, to the x power now I want this to be a fraction over 1 minus 1 over e. There we go. All right. So let me explain what I just did. We said that the infinite sum is e over e minus 1, correct? That means that this finite sum formula, if this were carried out infinitely, it would give us e over e minus 1. Does that make sense? If we use infinity for n here, take the limit of this as n goes to infinity, for those numbers, r is 1 over e. A is 1. Put those numbers in here, carry this out to infinity, our sum would be e over e minus 1. So what I did here is, I put E over E minus one, that's the infinite sum, that's this horizontal line. And then I put our numbers into that formula. A is one, R is one over E to the X power, one minus R, one minus one over E. Here's our sum, and it is converging with that horizontal line. You see that? Meaning its limit is E over E minus one. Okay? Now, that was just to hopefully give you evidence that this is correct.
True.
True. Yeah.
It's biblical truth.
All right, we'll stop there. I had two more geometric series examples to do before I go to telescoping series. The assignment is posted. I have not covered it all. If you did play around with it, do the ones that are can do with the things I taught you. But when you get to something with an infinite decimal, I'm going to do an example of that on Wednesday. And anything that's telescoping, I'll do that on Wednesday. Right? Have a great day.
Okay, so it's doable?
Oscar, Pedro.